Hi everyone, thanks for coming today. My name's Keeley, and I'm going to be speaking about building debuggable servers in Go. So first, a bit about myself. I'm an engineer at Improbable, and previous to working at Improbable, I was doing my master's in computer systems at MIT. So what Improbable is it's a company that builds technology for enabling massive scale game worlds. This is my first SREcon, so I'm excited to have the opportunity to present to you all today. So my plan for this talk is, to begin by speaking a bit about why building production services is hard. I'm then going to talk about existing solutions, which are designed to help make the building of production services in Go a bit easier. Next, I'll present Radical, which is a project that Improbable plans to open source this fall, which is designed to take a different approach towards making the development of production services in Go easier. And finally, I will cover some key takeaways from the talk. So this section of the talk will be on building production services and why this is hard. And for this section, there will be a bit of code, so if it's hard to read or if you want to refer back at a later time, feel free to look at the code at this GitHub link. I also want to point out that I have a couple of definitions on some of these slides. These are not meant to assert that this is the correct definition, rather just so we all have an understanding of what I mean when I say, for example, a service. So what we're going to do here is we're going to build just a very simple Go service, so you can understand what that looks like if you've never built a Go service before, and so that then we can naively iterate on adding production features to our service. This will then give us an opportunity at the end in a demonstration phase to show how we could run this service, this very basic service, using Radical, which is the project that Improbable plans to open source to make the development of your production servers in Go a bit easier. So if we want to create a service, the first thing we need to do is we need to define the protocol. What can be said between the client and server, and how? At Improbable, we use Google's protocol buffers, protobuf. So this enables us to define our services and then generate client and server code, which our application will actually call. So protobuf enables us to define two things. We have services and messages. So a service is a collection of actions that a server can perform at a client's request. And messages will just be the content of these requests. So here we have this greeter service, and it exposes just a single method, say hello, which takes a hello request and will return back a hello response. So once we run this protofile through the protobuf compiler, proto-C, we will have some interfaces generated for us. We can then implement these interfaces. This is a basic implementation of the say hello endpoint, where it takes in a Go context and a hello request, and then if this request succeeds, we should return back a hello response. If it fails, we're going to get back an error. And this is the core business logic for this service, which is basically just returning a string message which greets the name specified in the request. So this service, as it is, it's just sitting in memory. We have no way to actually communicate with the service. So what we're going to do is we're going to add a transport layer, or sorry, communication. So here I've decided to use gRPC as the communication protocol. This is similar to HTTP, but it actually uses protobuf for its service definitions, which means that the client and server code that we can already generate from our protofile speaks gRPC, which makes it quite convenient to use. So then, to begin listening for requests to our very simple service, we basically just define a TCP listener on the port we want to bind our gRPC server to. We create an instance of the gRPC server, an instance of our greeter service, and then we register a greeter service on the underlying gRPC server, and we can begin listening for requests. So the reason I want to walk through this naive implementation is so we can then think about what we need to do to make this service actually ready to run in production. As it is, it's not really production ready. If we want to run something in production, we probably want to have some kind of understanding of how the service is actually running. What are the requests that are hitting it? What is the latency? Things like this. So perhaps we want to add some metrics to our service. So in a very basic case, we could say we have a globally defined hello count, and for every request that comes in, we're going to increment a counter with the name that's specified in the request. Most production services will probably also have some form of logging. So in this simple implementation, maybe we want to log the communication protocol, the name of the endpoint, and the name specified in the request. So what you can see is we're kind of starting to add more logic that's outside of the core business logic to this service. We might also want tracing, for example, to understand these requests a bit better. And perhaps to make sure this service is actually stable, we want to limit the number of requests that clients can send to our service. Maybe we also need authentication. We possibly also want to have some form of retry policy. These are a bunch of different functionalities, and it's not even touching on all of the functionalities that would be required to run the service in production. So what we see is that building production services is hard. And it's hard because it requires so much supporting functionality on top of the core business logic for a service. Even though the implementation of a service itself might be relatively straightforward, as is the case with our greeter service, which just says hello, adding the functionality required for metrics and logging and rate limiting and all of this adds a bunch of additional code. So Improbable is hardly the first place to notice that there could be ways that we could make the building of production services a bit easier. There are some projects that already exist in the Go community to help with the development of production services. Show of hands, has anyone heard of, for example, GoKit or GoMicro? So a few people, yeah, these are pretty common. I will very briefly touch on these, and I can provide links at the end if you want to do more reading on these. But what GoKit is it presents itself as a standard toolkit for building microservices. It promotes this model of this onion model. And what this is intended to do is to have a clear separation of concerns between your core business logic and the supporting functionality. So we see at the core of the onion is the business logic, and surrounding this is the service-specific logic that makes up the service domain. Surrounding the service domain, we have the endpoint domain, which is where our service is abstracted to a generic GoKit endpoint. And finally, the outermost layer is the transport layer, where we actually connect concrete transport to our service. So this is nice in that it enables you to clearly separate out what is your service logic and what is functionality that perhaps could be provided by GoKit itself. GoMicro works a bit similarly. It's an opinionated framework for building applications with a pluggable architecture. So as long as your application conforms to the structure that Go microservices are intended to have, then you'll get a lot of things provided out of the box. So why did we not use this at Improbable? Well, for one, we've been building production services in Go at Improbable for a while now, before some of these libraries were publicly available or stable. Additionally, we wanted to have a bit more flexibility into how we built our production services. So what we did is we built something that we called Radical. So I'll give a bit of an overview on what Radical is, and then a demo where we're going to take our greeter service and we're going to try to run our greeter service using Radical. And finally, I will speak about some of the benefits of using Radical. So first, what is a radical? A radical is it's the bit of the plant embryo that develops into the primary root. So the reason for this name is because Radical provides a base server for growing out all of our Go services. So what it actually is it's a drop-in replacement for your pre-existing gRPC and or HTTP servers. So what this means is it introduces no new concepts. It just provides a server. And the functionality for the server is going to come from pluggable middlewares. So it's very flexible. You can write your own middlewares. You just need to have middlewares that take an RPC and return back a same RPC. And you can also take advantage of interceptors that are available in the community already. So for example, the Go gRPC middleware library has a bunch of different middlewares that you could use. Prometheus, for example, would include a middleware that you could use for metrics. OpenTracing has a middleware that you could use for tracing. And finally, Radical is well tested. It forms the basis of all of the production services that we've been running at Improbable, so we're fairly confident in how the base logic works. Now, I want to try to give an intuition of what Radical actually does, how it works, what problem is it trying to solve. And then hopefully this will be even more clear when I do a quick demo. So we've talked about one service. We have just the greeter service. But if we're running with a service-oriented architecture, we probably have dozens, or at scale, perhaps even hundreds of individual services. So this is a lot of code, it's a lot of work, but what's important to note is that a lot of the functionality that's in any one of these services is actually required by a huge number of different services. Everything outside of the service-specific logic is probably duplicated across a number of different services. So imagine we have service A. And service A, it needs metrics, logging, tracing, and rate limiting. We then have service B, and service B has all the same functionality, but in addition to this, it exposes a protected endpoint. So it requires authentication. And finally, we might have service C, which also has a protected endpoint, so it also is going to require authentication. What we can see is that we have common functionality being duplicated across a number of services. This isn't great, because it means if we have a bug in one service, we need to track down this bug in a number of different services. If the developer for one service adds a new kind of rate limiting logic, it's not immediately available to all the other services. So what we'd like to do is we'd like to minimize the amount of duplication that comes from the supporting functionality of our services. So a gRPC server can actually hold multiple services. So one logical solution is we could take the common functionality that's in each of these services and extract it into the underlying gRPC server. But we can actually take this one step further because in a production system, we probably have a number of different servers. What we can do instead is we can create a common base server. This base server will then hold the functionality that's shared between these different servers. And this is really what Radical is providing. It's providing a common location for all the shared functionality between your different services. So what does this actually look like if I was trying to run my greeter service using Radical? I'll see if this demo works, but what we'll see here is we define some flags, which is this visible? Yeah. Which have the ports. We can parse these flags. And then the functionality that we want to implement for our server is going to come from this interceptor pattern. So interceptors are gRPC equivalents of HTTP middleware. And here, we could, for example, include the server interceptor from the Prometheus package. And what we see that that includes is it basically has default server metrics. So it takes in an RPC, and it's going to return back an RPC, and it's going to then allow us to collect very basic metrics. We could also include the panic recovery. So panic recovery, we can see what this looks like. This is part of the gRPC Go middleware package. If our application panics, instead of just crashing, we can have some way to actually deal with this panic. And we can then pass these interceptors into our Radical server. And what this enables us to do is it enables us to, for example, have a default server interceptor chain. So at Improbable, we have a default chain of interceptors that most of our services run with. This means that if I'm creating a new service, I don't necessarily need to think about all these individual parts. I can inherit from this default server chain, or I can inherit these default interceptors and get a lot of functionality provided out of the box. And then we see here, same bit where we're going to create an instance of our Hello World service, and we're going to register our service on the underlying gRPC server. And finally, we can actually serve the service. So what's nice is that if I run my service, then I not only am able to get it up and running quickly, because this is actually going to serve my service over both gRPC and HTTP. I just didn't have time in this talk to go over the HTTP portion. But it also provides me with debug endpoints. So if I look at localhost, the status page, what I see is some general information about my service. So this was obviously, I didn't build anything, so I don't have build information. But if it's a service that we're actually running in production, we'll have information about when it was built, the commit hash it was built from, what version of Go it's running, all of this. And it also includes links out to other pages with useful information. So, for example, because I included the Prometheus interceptor, I see that I get my default service metrics provided just by default. We also see that because I used FlagZ, it's an open source library for dynamically changing flags in Go, I can see all the current values of the flags that are running with my service. Furthermore, if I want to debug something and I need some profiling information, I could, for example, search for goroutine leaks by looking at the goroutines provided by the pprof package. So yeah, this is just some basic information on the status page. And what you can also include, which is not in this demo obviously, but if you were running this in production, is links out to relevant dashboards and Grafana or Elasticsearch or whatever you want. So if we jump back into the slides now, we can see that we get a lot of benefits from centralizing and unifying this common functionality in a single package. For example, we get guarantees around basic operability of our service. So if I create any service and I use the default server interceptor chain that we include, then I will be able to see information such as the errors of my service and the latency of requests. Furthermore, it standardizes services, which has a lot of value. So if I want to start looking at a new service that I've never worked on before, it looks pretty similar to other services I might have worked on, which allows me to get up to speed much more quickly. Additionally, this infrastructure is shared between different teams at Improbable, so even if I'm working on services that another team owns, it still looks really familiar. Third, it promotes reusable service infrastructure. So if someone wants to add a new type of functionality to services, and they implement it using this interceptor pattern, then all I have to do is include this interceptor in my service to get the benefit of the work they've done. And finally, it reduces development time. Because so much of this functionality can be shared, you can really build on the work that other people do, and enables you to get your production service running more quickly. So those were the main points I wanted to cover. So for some key takeaways, these are all quite related. There's just 3 of them. One is that production services require a great deal of functionality outside of the service level logic. So they are almost all going to require some type of logging, some type of metrics, tracing, panic recovery, all of this. And we want to have some way then to not have to redo all this logic every time we build a new service. We don't want to duplicate common functionality across multiple services. And there's a lot of ways that you can try to tackle this problem. Radical is just one option for doing so, and it aims to help you simplify the development of your production services. So that's about all I have to talk about. I will take questions, but I do want to put in a quick plug for our other open source projects. We have a lot of them. My colleague Dom gave a talk about Thanos at the Lightning Talk session last night, and we have some other ones. Feel free to take a look. And we are hiring, so feel free to talk to me or a number of my colleagues wearing the shirt with the logo in the upper left corner. Thank you.
Any questions for Keeley?
What's the difference of this service and a service mesh?
Yeah, this is a good question. So the question was, what's the difference between something like Radical and a service mesh? So a lot of the functionality will be similar. This is a bit more scoped. It doesn't provide as much functionality as a service mesh, and it provides it in a different way. So for example, we are looking into things like Istio or other service meshes, but this is, for now, how we're building the services, and it's basically going to be a little bit less configuration to set up. This is solving a smaller problem, I guess I would say, than a service mesh. Yeah, any other questions?
So thank you for your talk. As someone who works somewhere that hasn't yet gone down the microservices route, sadly, how does this compare to things like using Nginx with Lua to do, to doing these metrics stuff at that level? How do you find that compares to that approach? I don't know if that's a useful question, but it's the one I have in my mind, so there we go.
Yeah, I'm not sure if I fully follow the question. How does it compare to using Nginx with Lua? Sorry, I think the sound's a bit odd.
Oh, there we go. Sorry. Nginx, famous HTTP server. There's a thing called OpenResty, lets you use Lua code to add basically middleware like you've done using Radical and your gRPC middleware.
Yep.
And I didn't know if that was something you come across. Basically, to simplify the question, how do you feel this compares to having, for example, a reverse proxy that's doing the metrics collection? I guess that would be the kind of thing I meant.
Okay, that makes sense. Yeah, that's a different approach. So, for example, having some type of reverse proxy that is looking at the traffic between going into services or going out of services and handling some of this functionality. What I would say is I think this is just a different approach to that. The concept is similar. You're trying to separate the concerns between the service level logic and things that shouldn't be specific to any one individual service. So I would say mostly just a difference between approaches. Yeah.
Any other questions?
Just a brief question. I assume that this only works for the Go environment, so you can't use this for anything else than Go right now.
Yeah,
correct.
We built this to help us build Go services. I think there's similar packages for other things in other languages, but no, this is specific to Go.
And any other questions?
Hi. How do you handle versioning and rollouts and the issues since basically this is sort of like a monolith replicated into all your services?
So
we have the same issue though.
What?
We have the same issue.
So I would say it's not really a monolith in that it's not that, this perhaps was a poor explanation, but it's not that they're all using the same server. It's that they're all like instances of this server, so they all have the same patterns, but they're rolled out as individual services. So just because they're all inheriting from this Radical service, base server, they are all rolled out separately.
Yes. This is what I understand, but let's say Team A. Let's say Team A using Radical, and Team B using Radical, and Team C using Radical for multiple services.
Yeah.
And there is probably one repo that you all contribute to Radical, right?
I see.
Let's say there is an issue in the Radical service, like in the common library itself.
Yeah.
And people using multiple versions of the Radical server and multiple services.
I see.
And if there is an issue, so you see where it goes, right?
Yeah. So at any one time, we only have one instance of the Radical server itself, and then the versioning, or if people are using different variants, this would be more in the actual interceptors that they were using, rather than, because the Radical server itself is like quite bare bones. Really, all the functionality is coming from these interceptors. So if there's a bug in something, it would probably be in one of these interceptors, and you would swap out the interceptors that you're using with your Radical base server.
Inform, announce all the teams, hey, we found this bug, please replace to a different version.
I think we're running out of time. So
yeah,
catch Keeley out at the Improbable booth, and please thank Keeley once again for her talk.